So we look at this problem, and again, we look at the operations that are involved. And we go through that checklist of operations that have problems. Here we have no division, but we do have even roots. And we know we cannot have even roots of negative numbers. Here we actually have two inequalities to deal with. So we would first look at the stuff in the x minus 1 and say, okay, well, that's got to be greater than or equal to 0. It's okay to be 0, but it can't be negative. Okay, well, that would lead us to saying that tells us x has to be greater than or equal to 1. So immediately we know for this to work, for this to produce an actual answer, x has to be greater than or equal to 1. If it's not, then that first radical is going to have a problem, and our whole thing then won't be real. Additionally, we have the inequality, the other radical, 1 minus x has to be greater than or equal to 0. That leads to 1 has to be greater than or equal to x, or specifically, if you want to rewrite it the other way, x has to be less than or equal to 1. Then we need to take our two inequalities and put them together. You have multiple inequalities. You want to put them together into one general statement. So for the first radical, you must be bigger than or equal to 1. For the second radical, you must be less than or equal to 1. Well, if you draw a number line, there's 1. Now both inequalities are including that 1, so I'll make that a solid circle. The first inequality says, hey, I have to be bigger than 1. So in other words, I have to be all the way up here. Everything up here. The second inequality says, hey, I have to be smaller than 1. So I have to be everything down this way. And since both of those inequalities are coming about from parts of the same equation, then they have to both be true. So we can only take the values where they're both true. And in this case, that would be where? Where are both those inequalities true? Only when x is 1. So therefore, the domain of our function isn't too interesting this time. The domain of h is just a set containing the number 1. Nothing else works. This function will only give a valid answer when x is equal to 1. Otherwise, it will produce a non-real answer.